Okay, so good day everyone. Our project is the infinite slope factor of safety calculator. The factor of safety, or FOS, shows how stable a slope is by comparing existing and driving forces. This program provides a fast and simple way to compute FOS using the infinite slope method, and it can save results and generate graphs for analysis.
So for this section, I'll briefly explain the workflow of the program from user input to FOS interpretation. First is user input and validation using read float and get inputs interactive. These functions make sure the values entered are realistic and acceptable. So if the user inputs something invalid, the program automatically requests a correction. Next, the program offers preset soil profiles to choose soil scenario. Users may select loose sand, dense sand, soft clay, or stiff clay, each with typical soil parameters. A custom option is also available for more specific cases. With all parameters ready, FOS computation begins using compute FOS, applying the infinite slope equation to calculate the factor of safety based on the slope and soil conditions. Finally, result interpretation using interpret FOS classifies the FOS value into less than 1 means failure likely, 1 to 1.3 means marginal, 1.3 to 1.5 means typical, and more than 1.5 means safe. Through this structured process, the program ensures reliable outputs and provides a clear understanding of slope stability conditions.
So for data storage, the program saves each FOS computation to a CSV file or results CSV and also inserts the same record into a SQLite database, FOS results DB. CSV is for quick viewing and sharing. The database supports organized storage and create, read, update, delete operations through the database menu. So for visualization and utilities, the plot FOS graph function plots factor of safety versus slope angle so users can see sensitivity visually. Utilities include help, default engineering constants, common soil profiles, and about. This provide guidance and reference values. And for menu system, the main menu routes user to compute FOS, view CSV results, plot graphs, open the database menu, or access utilities. The database menu allows viewing all records, updating a record, or deleting a record. This menu-driven design keeps the program organized and easy to use.
For our program demonstration, we'll proceed to online GDB for better presentation. So today I will demonstrate how our infinite slope factor of safety calculator works. First, when we launch the program, the main menu is displayed. Here, the user can see the different options such as computing the factor of safety, viewing saved records, plotting graphs, and accessing the database. For compute of factor of safety, I will compute the factor of safety using a preset soil profile. So, for example, I will choose number 1, and then I will choose loose sand. After that, I will enter the slope angle and the height. Then the program automatically calculates and displays the factor of safety together with its stability interpretation. So next are the input validation or error handling. For example, I will put another one, and then if I put a negative angle, the program will tell me that try another value because it is negative. So you can see the program detects the error and displays a message asking for valid input. Then once I put a valid input, the program allows me to proceed with the height, and then it is now saved to the database. So for automatic saving of results, after computing the factor of safety, the program automatically saves the result. I will now show that the data has been saved in the CSV file and SQLite database. So I will click number 2, and then here we can see the stored input values, the computed factor of safety, and its interpretation. This feature allows the user to keep the records and review previous results easily. So next.
Thank you, Mr. Timothy. For my part, I will demonstrate the database menu. First, open the database menu by click the number 4 so that I can choose to view, update, or delete a record. If I select view all record, the program shows all saved slope calculation with their IDs and parameters. Then, if I choose update, the program asks for the record ID, lets me change the values and save the update. For example, I like to change ID number 1, just click 1, then assume values of parameters, then it will save the update. Then lastly, if I choose delete, it asks for ID and confirms before removing the record. For example, I like to delete ID number 2, click number 2. And that's all for database menu. Let's move on to plot FOS versus slope angle. First, click plot FOS versus slope angle. Then ask me to enter the soil and slope parameters. Then after that, give the value of the parameters. After that, it generates a graph showing the factor of safety and different angles. Then that's all for plot FOS versus slope angles. Then lastly, that I demonstrate is a quick tour of the extra features. First, the help menu. Let's click number 5. Help menu explains how each function works. The next, the default engineering constant. Just click number 6. Default engineering constant provide typical soil values. The next, the common soil profiles. Just click number 7. Common soil profiles that show example soil types. And lastly, About section, just click number 8. The About section that explains the purpose of the program and its developers. And that's all for my parts.
This program can compute and interpret the factor of safety, save results to files and a database, and generate FOS graphs for analysis. It is a helpful learning tool for civil engineering students, though it is limited to assumptions of the infinite slope model. So thank you for listening and goodbye.